We're looking here at the concept of force and momentum and when each of those terms should be used, their definitions, and looking at them from a sports scenario. So it's important to understand first the difference between what a force actually means and what momentum means. Now, force is something that may produce motion. It acts on an object or the human body, and it has a push or a pull effect. Now, if that force is strong enough, it can produce motion, or it can change the characteristics of motion, so perhaps it can change direction. Momentum, on the other hand, is a measure of a characteristic of motion and how much motion an object or a body has. So it's measured when something is moving, because how much momentum something has depends on how heavy it is, so its mass, times the velocity, or how fast it is moving in a particular direction. So something that is very heavy and has great mass and a moderate velocity will have more momentum than something that has a light mass and moderate velocity. And a good way to think about momentum is that if that object or body hits something, how much impact force would that produce? Because force is something that acts on a body. Momentum is a characteristic of movement, how much motion something has. Now, in this example here, the ball is still. It has no momentum. So if something is not moving, it cannot have any momentum. Now, when that ball is sitting there, muscular force is acting on it. If it was to be let go there, gravity would act upon it and pull it down to earth. If it was rolled, friction would act on it to slow it down. So these are all forces that act on something, in this case, a lawn ball, to change its motion. Now, just before I said that a force can change direction or can change the characteristics of motion of something when applied to something, or it can change the shape of something. But in order to actually do that, the force has to be strong enough to overcome the inertia of the body, and inertia is related directly to mass. So a good way to think about this is you're moving house and you've got a box, and that box is filled with books, so it is very, very heavy, and you want to push that box to the front door. You try and push, so now you're applying a force to that box. It's a muscular effort force, but you cannot move it because it is too heavy. So its mass is too great, and therefore it has a very high inertia. It's very resistant to movement, and even though you're applying a force to it, it does not move. So that force that you apply has to be large enough to overcome the inertia of a body. So I've just said that force can be produced through muscular effort, and if you have more muscular effort, it will produce more force. Once the force acts on a ball, the ball will accelerate. It will move, and in this case it's going to move along the ground or maybe slightly through the air. And we'll talk soon about how that equation comes into play. When we look at the statement in italics, we're looking at Newton's second law. So the acceleration of an object, so how the rate of change of its velocity, is proportional to the force acting on it and inversely proportional to the mass of an object. So acceleration equals force divided by mass. Now what that means is that ball there that we're looking at, that lawn ball, its mass is stable. If you bowl that ball with more force, it is going to accelerate faster. And that's what that concept means, that if you apply more force to any given object, it will accelerate faster. Now, once this ball has started moving, now it has momentum, it has velocity, so how fast it's moving in a given direction, and it has mass. Then it will hit an object, and that will impart a force. So that force will generate a movement on another object. So the statement again, Newton's second law, the acceleration of an object is proportional to the force acting upon it. So the more force applied on an object, the faster it will accelerate. And it's inversely proportional to the mass of an object. So what that means is for any given force, if you've got something that's heavier, it's not going to accelerate as much. So let's look at these two balls. So we've got a 10-pin bowling ball. I'm going to call that the green ball. We've got a lawn ball. I'm going to call that the black ball for simplicity. Obviously, the green ball is heavier. It's got greater mass. If you apply the same force to these two balls, you bowl them with the same muscular effort, the green ball will accelerate at a slower rate because it's got a larger mass. And that just makes common sense. Now, once each ball is set into play, if they have the same force applied, if you were to measure momentum immediately after the ball has been bowled, it would actually be very similar or identical, because momentum is worked out as mass times velocity. So one's going to be moving faster, one's going to have greater mass, and instantaneously that's going to balance out. However, as soon as it starts moving, you get other forces coming into play, like friction, air resistance. That will change very quickly. So if we go back to that concept, more force will need to be applied to the green ball. It will need to be bowled with more force, more muscular effort, in order to ensure that it accelerates at the same rate as the black ball. Now, if they're accelerating at the same rate, because more force has been applied to the green ball, which ball will have more momentum? It's going to be the green ball, because the velocity is going to be the same, but the momentum is going to be greater in the green ball because the mass is greater. Now, in order to generate force, and we're talking about muscular force or muscular effort, we actually use the concept of momentum. And this concept that we use is summation of momentum. The concept of summation of momentum is particularly relevant when we're trying to throw for distance. Large muscle groups move first, and they build momentum before they transfer it to small muscle groups, and this allows maximum application of force. You would have to do a different style roll when you're looking at the one above, when you're not going for distance. You've got to work out the appropriate momentum in order to impart the appropriate force or muscular effort on the ball. When you're looking at javelin or when you're kicking an object, you want to have as much momentum as possible so you can impart the biggest force, biggest muscular effort. Having that large range of motion allows for the summation of momentum. It also allows for more time over which that force is applied, that muscular effort is applied, which increases the concept of impulse, which is just related to time. So more time generates more force, therefore you're going to be able to throw with more force or more muscular effort. Take badminton now. To create more force, the concept we're just speaking about, you need to generate more momentum within your body. Now, in this particular instance, we're looking at angular momentum, because angular momentum is something about rotation. It's around a central axis. And what we're looking at here as a central axis, we're looking at that shoulder. You can see that shoulder moving here. You can see that arm moving here. So what we're looking at here is the axis of rotation. And we're looking at the way the arm moves around that there in order to impart the most amount of force on this particular shot. Now, angular momentum, so the amount of motion in something that's rotating, is worked out as moment of inertia, and moment of inertia is worked out as mass times radius squared times angular velocity. So angular velocity is referring to how fast something's moving when we're talking about rotation. Now, if we're wanting to try to build angular momentum, we can try and build the moment of inertia, or we can build angular velocity. If we can build moment of inertia and keep angular velocity the same, we'll build momentum. Also, if we build angular velocity but keep moment of inertia the same, we'll build angular momentum. So by bringing the arm through here at a faster velocity, we can increase momentum. What we've got to be careful of when we're trying to build that velocity is that we don't take away too much at the moment of inertia. And you can see there that the arm, the elbow is slightly bent there. That's to help the arm get through faster, but we just want to make sure that we're increasing the velocity more than we're losing by decreasing the radius of rotation. So bringing your arm through quickly will increase velocity and therefore momentum, as I said, providing you don't lower moment of inertia too much. Again, that concept, if you apply a great range of motion, you've got more time over which the force is applied, increasing the impulse and therefore increasing the impact force. You're going to hit that shuttle with more force, and therefore that shuttle is going to move with more linear velocity. Here's another example. So we're going with light blue ball, dark blue ball, and white ball. Currently, these balls, none of them have any momentum. They're not moving. The dark blue ball is twice the mass of the white ball. So with this ball, in order to get it to move, and we're talking about moving the light blue ball, it's going to have a force acting on it. And that force, in this instance, is going to be produced with muscular effort. When in motion, the ball now possesses momentum, mass times velocity. As that ball is rolling, there's going to be forces acting upon it to change the momentum. That's going to include friction on the grounds and also the air resistance that it faces. And it's going to lose momentum as it rolls due to that change in velocity. As velocity decreases, the object slows down or decelerates. Now in this particular instance, the ball hits the other two balls at the same time, which creates an impact force. Remember, the force is a push or pull on an object to create motion. Now in this particular instance, the light blue ball is going to put half of its momentum into the dark blue and half into the white, and it's going to stop. That concept whereby the momentum is split between things that it touches, things that it pushes upon, the force that it creates, is known as the conservation of momentum. The force generated by that ball that's being bowled will produce motion in the other two balls. So it's going to hit, impact force, and the other balls move. But because they have different masses, they're going to move at different rates in terms of their acceleration. So because the acceleration of an object is proportional to the force acting upon it and inversely proportional to the mass of an object, and the white ball, has less mass than the dark blue ball, that white ball is going to move further because it's going to have greater acceleration. So you can see that dotted line is where they'll end up. So if you look at the numbers, I've just used some numbers in there for simplicity's sake. The dark blue ball weighs 10 kilos and the white weighs 5 kilos. Now both have been hit with the same force. If you look there, acceleration equals, that value 10 is referring to 10 newtons. And they're both being hit with the same because it's equal amount of force that each of them are being hit with. Then you divide that force by the mass of the object in order to work out the acceleration, how fast it's moving. So with the first one, its mass is 10 kilos. So 10 newtons of force divided by 10 kilograms, acceleration equals 1 meter per second. Whereas the white ball is 5 kilograms. So 10 divided by 5 equals 2. So what that means ultimately in terms of movement is that the dark blue ball will accelerate at 1 meter per second and the white will accelerate at 2 meters per second. It's going to go further due to its mass. Same force, lighter mass, go further. So what we've got here is that example. The white ball is going to go further because for the same amount of force, it has less mass, so therefore it's going to accelerate further. So just to go through it again, force is something that acts on an object to change motion, to produce motion, whereas momentum is something, a motion that, or a characteristic of motion that something possesses. And a really good way to think about momentum is that if that object that has momentum hits something, how much impact force would it have? If it's got a large mass, that's going to relate directly to momentum. If it's got a large velocity, that's going to directly relate to momentum.